And looking at this example, we should notice right away that we have a product of an exponential function and a trigonometric function. So we're going to have to use integration by parts here, and we're actually going to have to use it twice and then rearrange our equation to get the result. So integration by parts means pick something to differentiate, pick something to integrate, so u and dv. In this example, it doesn't matter what you pick for u and what you pick for dv, it'll work both ways. Maybe the easiest thing to integrate is e to the 2x dx, because the result is 1/2 e to the 2x. The derivative of cosine then is what we're left with for u, and du is then negative sine of x dx. Using our integration by parts formula, which, just to remind ourselves, I'll write over here for us, the integral of u dv is going to equal u times v minus the integral of v du. So that's your integration by parts equation. If this is u dv, or in this case u and dv, then we get u cosine x times v, which is 1/2 e to the 2x, minus the integral of v du minus sine of x dx. So there's plugging everything into the equation. We'll clean this up a little. I'm going to shift it out, and hopefully you'll see why shortly. We get 1/2 e to the 2x cosine of x plus minus and minus the integral of e to the 2x sine of x dx, meaning now we need to solve this integral, and to do that we're just going to have to use integration by parts again. So u is sine x and du is cosine x, and integrating we have dv is e to the 2x dx, meaning v is 1/2 e to the 2x. Sorry for the hesitation there, but I just realized that we made a mistake. This was integral of v du. V is 1/2, so this should actually be plus 1/2 out here, and this is 1/2 in here. So let's correct that mistake. It doesn't change our v and u and dv here, but we do need to include the 1/2 there. So continuing, we end up with this part staying the same, plus, now this integral, and we're going to do this. This integral changes to u times v, so e to the 2x over 2, or 1/2 e to the 2x, v times u, minus the integral of u, or minus the integral of v du. So v is 1/2 e to the 2x cosine x dx, and you notice I just added the dx up here. Trying to go too fast and make mistakes. So let's simplify here and see what we get. 1/2 e to the 2x cosine x plus 1/4, say 1/4, I'm right at 1/2, there we go, 1/4 e to the 2x sine x minus 1/4, and this quarter came from this 1/2 times this 1/2, the integral of e to the 2x cosine of x dx. And now we have another integral here, so integration by parts is how we'd solve this. But if you notice here, it's just going to keep repeating and repeating and repeating, because we're always going to get an e to the 2x and a trig function, either sine or cosine. But this part here in particular is the same as the question we're trying to solve. So this is actually an equality, so don't forget this is e to the 2x cosine of x dx is equal to that. Well, if these are the same pieces, then there's no reason we can't bring that over and make it plus 1 over 4 with this. So if we add those together, we actually get 5 over 4, 1 plus a quarter, times the integral of e to the 2x cosine of x dx is equal to 1/2 e to the 2x cosine x plus a quarter e to the 2x sine x, and this term has gone over here to get the 5 over 4. So the integral part is gone. Now we just need to get rid of the constant there, and we find that the integral of e to the 2x dx is equal to 4 over 5 times everything on the right hand side. Plus a quarter e to the 2x sine of x. So we could multiply in here with a quarter. Let's do that to at least simplify the answer fully. We get 2 over 5 e to the 2x cosine x plus 4's cancel 1 over 5 e to the 2x sine x. And since we've finished integrating now, we're going to add our constant of integration, so plus c.